Due to Earth's internal heat, we have plate tectonics on Earth, along with associated effects, like mountain building, volcanic eruptions, and earthquakes. The inner core is solid nickel iron. It is very hot and very dense. Above that is a liquid outer core, also made of iron and nickel. It is a little cooler and a little less dense. Above the outer core is a layer of dense silicate rock called the mantle. Convective heat flow within the mantle brings heat to the crust. How do we know that the Earth has internal layers? How do we know where they are and what they are? We have never gotten any samples of any layer except the crust. The answer is by analyzing the behavior of seismic waves, waves caused by earthquakes. They radiate outward from where they begin, and their speed and direction are affected by what they pass through. Every change in the path of the different waves shown in this graphic mark where the phase has left one layer and entered another. We will talk more about earthquakes later. Rotation of Earth's core and convection in the liquid iron outer core drive a geodynamo. This is the source of our planet's shield against dangerous particle radiation from the Sun. The stream of charged particles from the Sun is called the solar wind. This stream compresses the Sun-facing side of Earth's magnetic field and blows the other side out into a long magnetotail. The solar wind is probably the force that stripped away most of the water on Mars, along with quite a bit of its original atmosphere. This would be our fate as well, if not for our magnetic shield.
What comes to mind when you think of Halloween? Trick-or-treating? Jack-o'-lanterns? Ghouls and goblins? But the sun? Probably not. But just 5 years ago in the week surrounding Halloween, the sun sent us some tricks and treats of its own. The tricks were a series of some of the most powerful solar storms ever measured. Storms that disrupted power grids, communication lines, and satellites. But the treats were some extraordinary auroras, seen as far south as Florida and Texas.
The effects of these storms on the Earth were ghoulish enough that we had to reroute aircraft. It affected satellite systems and communications, actually caused a power outage in Sweden for about an hour. But I think generally the public was very excited to see the ghostly aurora that were created in the night sky. The aurora are normally limited to higher latitudes, and so these storms were so powerful that they created aurora that could be seen as far south as Florida. So you can imagine seeing these ghostly figures haunting the night sky.
In all, nearly 17 major flares erupted on the sun during those 2 weeks in 2003. The result of energy building up in the sun's magnetic field lines until they became strained enough to suddenly snap like an overstretched rubber band. The results were coronal mass ejections, the largest explosions in the solar system, able to launch up to 10 billion tons of electrified gas into space and cause some of the ghoulish effects we felt here on Earth. These storms were also eerie because they came at such a surprising time.
These storms were spooky because of the timing of which they occurred. That is to say that it didn't occur in a stage where most of the activity occurs. In fact, it occurred about 3.5 years after solar maximum occurred, so it was spooky in that respect. And it was also spooky in the intensity of the storms. These were some of the largest storms ever observed.
So can we expect to see any ghostly-looking auroras in the night sky this Halloween?
Well, I don't think we're going to see a repeat this Halloween on the 5-year anniversary because we're at a time where there are very little active regions on the sun. However, we are going to be ascending to a greater period of solar activity. So, we may see some large storms in the next few years.
Still think the sun isn't so scary? Hopefully this spooky tale will make you think again.
Earth constantly releases heat to space. The core heats the mantle and convection currents carry the heat to the crust. The amount of heat energy radiated by the Earth is 0.087 watts per square meter. The constant flow of internal heat drives the process of plate tectonics. Where convection currents rise, you get a divergent plate boundary. Each plate moves away from the other at this type of plate boundary. The mid-ocean ridges are an example of this. This graphic shows a spreading center along a divergent plate boundary on the ocean floor. As rock forms in the Rift Valley at the center of the ridge, it records the direction of Earth's magnetic field at that time. Earth's magnetic field reverses polarity, north becomes south, south becomes north, on a repeating cycle over time. A record of the field's past reversals repeats on either side of the ridge. And, the rocks become older the farther you get from the ridge. Divergent boundaries start on land. The Great Rift Valley, shown on the right image, is on a divergent boundary that is tearing Africa apart. This boundary extends northward running under the Red Sea. The Red Sea filled with ocean water as the Arabian Plate split away from Africa. New crust is constantly being formed at divergent plate boundaries. From left to right, Africa, the Red Sea, Saudi Arabia, the Dead Sea. The Red Sea is a site of active spreading, where plates are moving apart, creating a new ocean basin. This graphic shows a convergent boundary between an oceanic plate and a continental plate. Being denser, the oceanic plate is subducted beneath the continental plate. As it descends, melting occurs. Magma moves up through fractures in the continental plate, feeding the volcanoes that form. Mount St. Helens, which last erupted in 1980, is one of the Cascade volcanoes of our Pacific Northwest. Oceanic convergence results in a deep-sea trench forming at the subduction zone, and a chain of volcanoes that forms an island arc tracing the position of the colliding plates. The Aleutian Islands of Alaska are an example of this. In this image, you can see the Aleutian Islands from orbit. None of its volcanoes are erupting in this view. Continental plates can collide as well. India collided with Asia, and the resulting Himalaya mountains are still rising today as India continues moving northward. The Himalayas are relatively young mountains, and since they are still being uplifted, are the highest mountains on Earth. Other, older mountains, that are no longer being uplifted, get worn down by continual weathering and erosion. In Michigan, the Porcupine Mountains are ancient mountains that have been worn down by 2 billion years of weathering and erosion.
When we least expect it, when we're least prepared, disaster can strike. And few disasters are as unsettling as an earthquake.
So it's important for you to... Oh, Mike!
My guess is that earthquakes are really so scary because you don't have any warning. It's the only thing besides a nuclear war that can really, 1 second you're living in a big beautiful city, and 10 seconds later it's flat.
Every day the Earth is shaken by hundreds of small earthquakes. Most go unnoticed. They usually occur along the boundaries of the thin plates that cover the Earth like an eggshell. Driven by the heat deep within the Earth's core, the plates grind against each other on long lines called faults. When the plates find their motion blocked, stress builds up. Finally, the fault gives way. The released energy races through the Earth in the form of seismic waves. For much of the world, the movement of plates like these is also an indispensable creative force.
If we didn't have earthquakes, if we didn't have this great flow of heat from the interior of the Earth would be a cold, dead place. If it wasn't for this great flow of heat, there'd be no continents, no oceans, no atmospheres. The Earth would be as dead and dry and cold as the moon. It's really the earthquakes that create the topography, the valleys, the mountains.
Earthquakes have been shaping landscapes for eons. It's only in the last few hundred years that civilization has gotten in the way. And when it does,